Okay guys, so most of you guys were in class today, so you already did this for the warm-up. So you don't need to watch this video because it's already done for you in class. If you were absent or you didn't get it the first time, or this is 8th period, this would be a good thing to watch. Okay, when we're talking about domain, the domain is always going to be negative infinity to positive infinity for any function that is quadratic. So you can automatically fill in negative infinity to positive infinity for each of the functions, because we know that no matter what, the graph always goes to the left and always goes to the right forever and ever and ever and ever. In other words, the possible x values, the input values, are always going to be infinity. Okay, when I look at the range of this function, I'm going to look at my vertex. My vertex in this case is 4, 2. And when we talk about range, we are talking about the y-coordinates and where the graph starts and where it begins, or where it ends, if you will. Okay, this graph supposedly would end here, but it really has these arrows at the end, and it continues to go on forever. Okay, so your range has to do with your y-coordinates. So we're going to go from our maximum point, our highest point is 2. So it's going to go from negative infinity to 2. 2 goes last. It says, using this graph, write the function that would best represent a new graph translated 3 units to the left. You're going to take your vertex point and you're going to go 3 units to the left. 1, 2, 3. And then you're going to go down 5 units. So 1, 2, 3, 4, and 5. This is where the graph lands. It's going to look the same or similar to the previous one, and really all we're interested in is the vertex point. The maximum occurs at -1, -3. Whatever your y-coordinate is, that's what's going to be your maximum point or part of your range. Since the highest point is -3, that's where your graph ends. I'm going to put -3 last, and then put negative infinity in the front. Okay, let's look at the second example, number 2. The range for this function is going to depend on your vertex. In this case, your vertex is 1, 0. So your y-coordinate is 0, and that is the smallest point or the lowest point on the graph, so that's where we're going to start. It's going to go from 0 up to positive infinity. Okay, and it says, using this graph, write the function that would best represent a new graph translated 2 units to the right. So I'm going to get my vertex and I'm going to go 2 units to the right and 4 units up. So 1, 2, 3, 4, and I'm going to land here. So my graph looks similar to the previous example. It just has a new vertex. The vertex has been moved to the right and then up. So your range for this function has to do with your minimum. Your minimum is at 3, 4. Your range always has to do with your y-coordinates. This is your lowest point, so it's going to go first. 4, 2, and then how high does it go? Towards positive infinity.